What's up everyone, my name is Daniel Briggs. I'm going to show you a little bit about Havoc's reactor, which is built into 3ds Max. I'm going to teach you how to bake out physics animations using reactor. I'm going to show you a little bit about the basic tools that come with reactor. So let's get started. If you're following along with these tutorials, try and model out the same basic shapes I have. I'm always going to use a box for the floor plane, and I modeled out several basic shapes that I'll explain a little bit more about as I go on. So if you want to follow along, just pause the video and then do what I do. First thing I want you to do is go to the Utilities panel on the far right. You're going to open up Reactor, and you're going to click on Preview and Animation and the Properties tab. These two tabs are the main ones we're going to be using for this tutorial. Okay, whenever you want to preview your physics simulation, you click this Preview and Window button. If I were to click it right now, it says there are no entity collections, or they are all empty. This means that if you want to have a physics simulation, you need to add these objects to the physics simulation in some sort of collection. So the first thing we're going to show you is what a rigid body collection, and this is the most basic tool in Reactor. So I'm going to select the floor and all these boxes I created, and I'm going to click Create Rigid Body Collection. This little icon is going to pop up, and everything I had previously selected will be added to this collection here on the right. So if I were to go back to the Reactor panel, and I hit Preview and Window one more time, you'll see all the boxes will pop up. If I hit P to play the animation, nothing is going to happen. Everything's going to stay there and be static. You may be wondering, why is this happening? I just made them rigid bodies. Well, for rigid bodies to react like real-world objects, they need to have mass. And whenever you create a rigid body collection, if you go to the physical properties, mass is set to 0 by default. Anything that is set to 0 will never move. So for the floor, we want to keep it at a mass of 0 because we don't want it to ever move. We just want things to collide with it. For the rest of the boxes, we're going to change the mass to 25. We're going to hit Enter and preview it again. If we were to watch this animation, now all the boxes react as if they had 25 mass. They all fall and collide. Cool, that's exactly what we wanted. So we're going to X out of this. So now you understand the basic settings of this. There's mass, which is how much an object weighs. Friction is how much friction the object has when it collides with another object. And elasticity is basically how bouncy an object is. I'm going to go over these basic checkboxes on the far right that are in the Physical Properties tab, because these can help you a lot with some of your simulations. So right now, if I were to take this box and I were to click the inactive checkbox, basically what inactive does is it takes your rigid body and it says that it's inactive and it won't calculate any of its physics until another rigid body collides with it. So if I were to preview this animation with the second box in inactive mode, you'll see that this box right here, it will not move until this top box falls and hits it. So that's exactly what I wanted. Perfect. I'm going to exit out. I'm going to take off inactive. I'm going to check unyielding for this next demonstration. And what unyielding does is it allows you to animate an object and use its animation to collide with other physics objects. So if I were to set quick animation for this box right here, and in 20 frames I want it to move this far, right? You'll see that it animates like that. Basically, it will play this animation, and this top box right here will collide when it falls into this thing. But this thing will not react like a physics object. It will use its mass and friction and elasticity when something else collides with it, but it will always do its animation and nothing else. So let's preview this simulation and see what happens. There you go. This thing animates the top and it pushes that object out of the way. The other two, disable all collisions, is very self-explanatory. It just makes it so it doesn't collide with anything. The phantom object basically makes it so it can go through certain objects. So that's enough for the rigid bodies, and we're going to go ahead and move on to my next demonstration. So we're going to do the same thing we did. I just modeled out a bunch of boxes right here. And I'm going to take all these boxes and the floor once again. I'm going to add it to a rigid body collection. So I'm going to select everything, click rigid body collection, and it adds them all to the right once again. I want the floor to have a mass of 0 because I want everything to collide with it. I'm going to take all these boxes and give them a mass of 25 again. The same thing we did, so if we were to preview this animation, you'll see that all these boxes just fall to the floor. Cool. So the next tool I'm going to show you is called the fracture tool. And this works really well with rigid bodies, and it gives you a lot more control over what happens. So what you're going to do is you're going to select all your cubes that you want to be part of the fracture. You'll look at your reactor toolbar and look for a little box that's cut in half. It says create fracture. I'm going to click this object. Everything I have selected is once again added to this fracture. So if you were to click on the fracture and go to the modifier panel, you can edit like all the properties of the fracture. And basically what fracture does is it says, okay, if my objects become this velocity, then break apart. if my objects collide with something and it has an impulse greater than this integer right here, then break apart. So let's preview this simulation and see what happens. They all fall, and this very bottom cube took the most damage when it hit, so that thing broke apart. Another really cool thing about fracture is you can tell your objects when to break apart. So if I go back to the modify panel, I could select all my objects in my fracture, and I could tell them when I want them to fall apart. So I could say break at time, and I'm going to select a keyframe at 20 seconds, right? You could type it in, or you can click now, and we'll go to the current keyframe. So now at the 20th frame of my animation, all of these blocks will fall apart. So let's preview it one more time. They all fall, and at frame 20, they all separate from each other. Excuse me. This is very powerful. When you make a fracture, you don't have to select all the objects in your simulation. You could have, just these top cubes be part of a fracture. And you could say, okay, whenever they hit the ground, I want them to break into a bunch of pieces. And it gives you a really nice effect. Instead of everything falling apart at once, you can make it kind of break apart in sections when it really hits things. So that's the basics of fracture. The next thing I'm going to show you is a motor. And what a motor does is it takes a rigid body and it attaches itself to the rigid body. And basically a motor rotates on a certain axis and it will rotate the rigid body it's connected to. So I created a basic sphere right here and I have a ground plane. What I'm going to do is I'm going to add the ground and the sphere to a rigid body collection. Okay? And I need to give the sphere mass so it can fall and touch the ground, because if I leave it at 0, it's just not going to do anything. So I'm going to give it a mass of, let's say, 10. Now, the next thing I'm going to do is look over here on the reactor panel, and I'm going to click on Create Motor. It's this little sprocket icon right here. I'm going to click it on the ground. If you go to the modifier panel for the motor, you'll see that it says Rigid Body with a little box that says None. I'm going to click on None. I'm going to select a rigid body that I want the motor to affect. You'll see it pop up right here. If you want to see the motor better, you can change the size, and you can actually see which way the motor is rotating by looking at this arrow. Okay, so right now, the motor is rotating on the x-axis. So if I were to play this animation right now, I'm sorry. We're going to delete these previous rigid bodies because it's giving me a problem. Okay, I'm going to try this one more time. You'll see that it rolls along the x-axis. There you go. And in the modifier panel, you can change how fast the motor spins. You give it a cap for how fast it can go, and you can give it a gain of how much acceleration you want to give the motor. So that's it for this basic object. We're going to delete this again, just so we don't have any problems later. Okay, the next is reactor cloth. And the way we're going to make reactor cloth is, for reactor cloth, you can't use a plane. You actually have to model a really thin box. And the more subdivisions you have, the more accurate your cloth simulation will be. So right now we have this really thin box with a bunch of subdivisions. And I have this box below it that I want the cloth to fall and fold around. Then I have the ground just in case the cloth falls off. So what I'm going to want to do is select the cloth, go to the modifier panel. I'm going to make it a reactor cloth. There's an actual reactor cloth modifier. If I add this, you'll see all of its properties. These properties override the properties in the utility panel. These physical properties mean nothing to the reactor cloth. So now that we have reactor cloth, when you first create it, avoid self-intersections is checked off. You're going to want to check that box. It's going to make sure that the plane doesn't go, you don't want the two sides of the box to go through itself. So that makes sure it doesn't happen. Okay, now that this is a reactor cloth, you're going to select it and you're going to do Create Cloth Collection. Because if we want to have a cloth, we need to put in a certain collection. So we need to be a cloth collection, which means it will react like cloth. We're going to want to select the cloth, the box we want it to collide with, and the floor, and we want these all to be rigid bodies. Because nothing's going to happen if they're not rigid bodies. So right now, all of the cloth's properties are in the reactor cloth, so we don't have to worry about its physical properties. The box and the floor, we want both to have a mass of 0 because we don't want them to move. So if I were to preview this in window right now, you'll see that when I play it, the cloth will simulate and fall around the object. It looks really cool. So I have a baked out animation right here. Oh, I'm sorry, I forgot to say this. Whenever you want to create your animation, whatever you see in the preview window, if you hit create animation, it will make keyframes for all of the frames that happen in preview and window. So you set the start frame, the end frame, how many frames you want it to key, and substeps is basically how accurate your simulation is. The more substeps, the more accurate your collisions will be. So I use create animation on the same exact piece of geometry right here, and this is what it baked out. It baked out this cloth. Whenever you bake out a reactor cloth, it doesn't give you keyframes. When you break out rigid bodies, if you bake out rigid bodies, you get a bunch of keyframes at the bottom, but reactor cloth does not do this. It's kind of a problem because if your reactor cloth does something weird and you want to fix it, you can't fix it by changing the keyframes at all. But I made a really cool plugin using MaxScript, and I'm going to actually include this on my website right below this video, and I'm going to drag this in right now, and at the very end of this video I'll go over some of the code so you guys can see how I created it. And basically what this does is it keyframes your reactor cloth. You click on your reactor cloth, you click on my script, and once I run this button, it basically makes a copy of your original reactor cloth. So this is the original reactor cloth, and this is the one that my script did. And as you can see, it basically made a copy of the same exact cloth, but it keyframed all the vertices on every frame. So this is way more powerful than the first one, because the first one we can't edit anything. So for this cloth simulation, now that we have keyframes, if we really hate it how something happens, like right here, the vertices are going through the floor, I can auto key with soft selection, and I can actually fix this by moving it up. So the script is really powerful. These are the basics of Reactor, so I hope you guys learned a lot from this tutorial. Right now I'm going to go over my script. If you know anything about programming, stick around and hopefully I can teach you something. So I'm going to open up my script right now, and this is basically it right here. I hope you guys can see this. And basically what it does is it creates a rollout, which is a little window, okay? And then it also creates a button in that window. And basically it says, okay, whenever you click this button, it says on key button pressed, do this. So whenever you click the button, do all this code right here within these braces. Basically what I do is, whatever you're selecting, it makes an array of that selection. So you could actually bake out a bunch of different reactor cloths at one time and keyframe them. It says, for all of the objects in your selection, make a copy of that object and change the name. Instead of naming it the same exact thing, make it the same name with underscore keyframed at the end of it. It basically adds a suffix. Convert this to a new object, okay? And it's going to be an editable poly. And it basically says, set the variable number of verts to the amount of vertices in the original selection. So it selects all the vertices of the first object you selected, and then for each frame in your animation. So it basically says, okay, from start of my animation to the end of my animation, as long as it's animating, please do this. And it'll say, okay, for each of the vertices in my selection, copy its position to the new object and keyframe it. So basically, it takes my original object that I selected, it makes a copy of it, it takes all of the vertices from my first object, and it copies them into this new object for every frame. And after it does that every frame, it keyframes those vertices moving. That's basically all my script does. And that's what you can see right here. And at the very end of the script, so when you actually run it and that window pops up, you have to type create dialog and the name of your rollout. And this basically makes the button pop up. So that's about it. I hope you guys learned something. If you want to check out the script, you can download it off my website and look at the code. Hopefully my video can explain it a little bit better. Please check out my website at www.3dbriggs.com. Thank you.